Okay, all right, this looks like it's going to work. I think we better get some Lab 6 notes done here, just so that you're not, so that we can include these in the thing. I just put new ink into my pen, so it should last. Now, one of the first things we had to know, what is rho? What is, how many pounds? What is the air pressure? How many pounds per square inch? Because that's one of the questions that I ask you. Is in air pressure ballpark? It's about 14.7 pounds. I think maybe your answer might be 15 pounds on your homework. I'm having trouble with my LBS there, 15 pounds. Okay, and then we had a volume problem. How do you find the volume of a sphere? Let's say we've got a volume of a sphere. Then I have us do some other calculations later on too that get kind of scary. So that's why I probably won't get this video done today. I'll have to wait till tomorrow to get it because I just have to get ready for my other class here, and I got some other things I got to do. I ain't got time for you all. No, I'm just kidding. But anyway, so let's take a volume of a sphere. How would we do that? Because I think I asked you to calculate that. Let's say the sphere is in, and we want to make it in cubic meters. So let's say the sphere has a radius of 0.1 centimeters, or 0.1 meters. In other words, that's 10 centimeters, which is ballpark 4 inches. Okay, so that's a pretty big. That's a good size. That's a good size ball. I mean, that's a ball about like, this is 8 inches wide, so it's a ball about the size of this sheet of paper here. And so let's find its volume. Well, the volume is equal to 4/3 pi r cubed. All right. And so the way you would do this on a calculator is I'd put my parentheses and go 4 divided by 3. That gets you your 4/3. And then I'd do parentheses again, 3.14. And then I'd just take 0.1, 0.1, 0.1, and then press enter. That's the novice way to do it. That's for those of you who are like, wait, I have no idea how to do this on my calculator. See, my calculator would do it just fine, because I'd go, okay, well, 4 divided by 3. 4 divided by, show off. 4 divided by, and then I'd go second pi, and then I'd hit 0.1 to the third power. That's the way I'd do it. Bang. That's what I get. Now, let's see if yours would work the same way if you do it the way I said here. Parentheses, 3.14, parentheses, 0.1, parentheses, 0.1, parentheses, 0.1. Yep. Pretty darn close. I rounded the pi up here is much bigger than the pi down below. Okay, so that's how you find the volume. I ask you a question on that. How do you find the volume on something? Okay, well, that's not bad. That's not bad. Where were we on this? Okay, we were into why things float, and it's because they're less dense than air is the main reason. That's why they float. All right, so we look at some things. One of the things here is the good old lava lamp from the 70s. Okay, I've heard they're coming back. See, what happens is these little globs heat up. They get hot down here. That's on the lamp part. They're made of a different fluid than what they're in, and so this fluid is less susceptible to heating up. These things heat up more, so they heat up. They go up here, then they cool off, and they fall back down because they get less. Because they get as they shrink, their density increases because look at this. Here's the formula for density. All right, we've already seen rho, formula for density. Formula for density is rho is equal to the mass of the object divided by the volume. So if the mass stays the same, but the volume gets little, that means density increases. And when you work with math and science like every day, those kinds of relationships just come up all the time. You also don't know how to write. There we go. That's a little better. All right, I think I've probably yacked too much already on this one, so let's go ahead and cut this one off.